contain one acid radical, one basic radical is called simple salt. This is a simple salt. We are going to identify the acid radical and basic radical present in it. So, this analysis is done in 3 steps. First step is preliminary test. Second step is detection of acid radical. Third step is detection of basic radical. And fourth one is report on result of the experiment. Now, we are doing preliminary test. Preliminary test contains state, color and solubility. We are checking the state. See here, we observe here, the state is crystalline. We have to write state crystalline, then color is white or colorless. I am checking the solubility. Take a pinch of salt, hot water. First we check solubility in water. If it is soluble in water, we can put plus. If it is insoluble in water, we are put dilute HCl. See here, our salt is soluble in water. So, you are getting a clear solution. So, I am putting plus in water. So, original solution or salt solution is salt plus water. Second step of the experiment, detection of acid radical. We have to identify the acid radical. Detection of first group acid radical. See here, for first group acid radical, the group reagent is dilute HCl. See here, take a test tube, add a pinch of salt, and I am adding dilute HCl. Or you can add even dilute sulfuric acid also. Salt plus dilute acid. See here, I am not getting anything. No brisk effervescence. No brisk effervescence. So, first group acid radical is absent. Detection of second group acid radical. Salt in a dry test tube. We have to take salt in a dry test tube plus concentrated sulfuric acid. Salt in a dry test tube. Add concentrated sulfuric acid. A colorless gas which gives dense white fumes. See here, a colorless gas award which gives a dense white fumes when glass rod dipped in NH₄OH is held on the mouth of the test tube. See here, first I am getting colorless vapors which becomes a dense white when glass rod dipped in NH₄OH. This gives an identification of chloride ion. Acid radical chloride is present. Confirmatory test for Cl minus ion, that is chloride ion. Take a salt solution. Take a salt solution. Add silver nitrate solution. Salt solution plus AgNO3 solution. Salt solution plus AgNO3 solution. We are getting a curdy white precipitate. You are getting a curdy white precipitate. For this precipitate, I am adding excess of NH₄OH. Now, see here, I am adding excess of NH₄OH. Precipitate is completely soluble. See here, the precipitate is completely soluble. See, the PPT is completely soluble in NH₄OH. The precipitate is completely soluble in NH₄OH, which confirms the presence of Cl minus ion radical, chloride radical. So, given acid radical is Cl minus. Basic radical. So, basic radicals contain 6 groups. 0 group, first, second, third, fourth and fifth group. So, first I am checking for 0 group basic radical. For 0 group basic radical, you take salt. Detection of 0 group basic radical, I am taking salt. For this, if you had NaOH, salt and NaOH. Shake well. Also, if necessary, you have to heat also. Smell the gas. Now you are getting a pungent smell of ammonia gas is evolved. Here, salt plus dilute NaOH. Smell the gas. I am getting a pungent smell of ammonia gas evolved. So the result of this is you are getting NH4 plus. Your basic radical is NH4 plus ion. 0 group basic radical present, NH4 plus present. Confirmative test for NH4 plus ion, that is NH₄Cl reagent test. Here, for doing NH₄Cl reagent test, I am taking original solution. This is original solution, salt plus water. Take original solution and NH₄Cl reagent. This is NH₄Cl reagent. I am adding NH₄Cl reagent. See here, salt plus NH₄Cl reagent. So for this, I am adding excess of NaOH. Salt plus NH₄Cl reagent. Then add excess of NaOH. Now see the test tube. Salt plus NH₄Cl reagent plus excess of NaOH. You are getting brown precipitate. Formation of brown precipitate indicates that the given basic radical is NH4 plus. And now we have to report the salt. So report is